Yeah, before we launch into it, I just got to do this thing that I've been thinking about doing for a long time, and that's to stand up here and say, cloudy cloud, 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 cloud in your cloud. Yeah, it's a buzzword. We're going to demystify that a little bit, and I'm not going to attempt to convince you to look at cloud stuff. As a matter of fact, I have some pretty contradictory statements in here. And so just a couple operational definitions, also known as jargon. VoIP, right? Voice over IP. It means the packetization of voice over an IP network. So this is, the same network that runs on your Ethernet, on your fiber. That's what we're talking about when we say VoIP. In stark contrast, we have analog, which is the transmission of audio over a pair of wires. So this is the technology from the late 1800s, Alexander Graham Bell stuff. This is, the speakers that are going in the back of your hi-fi system, analog. PSTN, public switch telephone network. And when you make a call on your cell phone, it hops onto that thing and then hops off somewhere else. It's kind of like the internet of the telephone world. SIP, STAT stands for Session Initiation Protocol. And that is the protocol that a VoIP system today, like a modern one, would use to talk. And it's a language, a protocol that devices use to talk to other devices, servers, phones talk to a PBX, trunks. You've probably heard some of these terms, but anymore, it's probably all using SIP. And we may go into that a little bit more, but not too deep here. All right, rolling on. So what I want to start with is defining the applications. And these are really the parts of the collaboration system that we care about. What is this thing doing for me? And I was hoping we had a 4K screen or something, so I'll just read this stuff out to you. So starting at the top, the traditional phone and voicemail. So if you ever hear someone say, I just need dial tone, they're saying, I just want a phone system to do what a phone system should do. Make your internal calls, your outside calls, have a directory, be able to transfer, hold, conference. This is all the stuff that we're used to and that phone systems have been able to do for a long time. All right, cool. Attendant console, also known as a switchboard. So if you have an organization and there's somebody who mans the phones, and that's their primary role, primary responsibility. On an older system, this might look like a phone that's got a console from the Death Star with all these buttons and everything. That is called they call it a switchboard. That's an older term, but that's what they're talking about. Attendant console can also be software. It can be a computer program with a grid of extensions. A phone operator can drag and drop when they want to transfer somewhere. So that's attendant console. Traditional voicemail, it's in here. We all know what that is. Anymore, a modern VoIP system can, in at least two different ways, forward your voicemails to your email. So it can either do a simple store and forward, or it can do a synchronization with your email inbox, where if you get a voicemail, you also get an email. If you listen to that WAV file in there, there's a synchronization, and it also tells the voicemail box, hey, I've listened to, I've read this. If I delete it out of my voicemail, or my email inbox, it deletes it out of the voicemail inbox. That's a pretty common feature. It's been around. Call flows and auto attendance. So this is what happens when, maybe your district has a main number, or high school has a main number, and someone calls in. You don't want to load down those phone operators so much, and you provide them with a recording, and it says, hey, for attendance, press 2. To reach the athletic director, press 3, so on and so forth. That's what I mean when I say a call flow. And an auto attendant is just that object that plays the recording, that processes what you poke on the keypad to move within this call tree where you want to be. Analog/legacy. We talked about Alexander Graham Bell already. The reality is that this stuff is still all over the place in schools. I find it everywhere. Have you ever heard POTS line? POTS is plain old telephone system. It's still out there. It's everywhere. And we are very used to integrating with that stuff. Along with analog, we also talk about paging systems. And paging is kind of a hot topic. It can be your traditional overhead speaker. It can take the form of a power over Ethernet VoIP speaker that's in the wall that also has a little display that can read out, the time, a clock. It can do your bell schedule. It can provide useful information to your staff and your students. So.
I'm going to interrupt you. Move your mic slightly because that cord from your lanyard.
Yeah, let me just ditch this. How
Rustling.
about that?
Thank you. Sorry.
No, good deal. All right, so moving on, soft phone. And this is probably one of the more modern features. Soft phone is the ability for your, I'll say work phone, but a desk phone to live in software. So it's virtual. It can live on your PC, it can live on your smartphone, and it's an app in that form. It's a program, and it makes your mobile phone basically have two phones on it. You've got your native dialer, and then you have the soft phone, and it acts just like your native dialer. And it acts like an iOS or an Android. When you get a call, you get a screen, and it's got a red and a green blob. I hit the green to answer it, or red to decline. Soft phone does this, and unified communications is kind of this overarching term used to describe this, and it very much includes soft phone. So soft phone anymore is something that in general any modern unified communication system can do. There's also the ability for that soft phone to work outside of your school network. Sometimes that has to use a VPN to do it, sometimes it doesn't. Moving on, survivability. So this is something that's very near and dear to my heart. I got kids in school, so I'm always thinking, I always get in this perspective, like, how do I make sure that this phone system never fails to provide communication to this school? It's extremely important. And survivability is one of the layers in a redundant approach to phone service that can sustain basic phone systems if the main system goes down. We'll touch on this a little bit more later. Moving on. The instant messaging and team spaces, which includes content sharing. Another component of unified communications is the ability to provide this service to users to be able to do instant messaging. So in its earlier forms, this was like, AOL Instant Messenger, if you remember that. It's just a chat back and forth thing. Anymore, that has evolved quite a bit. It can be that, but can also include multiple people. It can be organized into these spaces. If you all have ever used Slack, Microsoft Teams, WebEx, this is the kind of capabilities I'm talking about. So you can have users from your organization being able to chat, share things in these rooms or one-on-one, and you can even have users outside of your organization join those when it's appropriate. And you can share files over that. You can even do whiteboarding. And the more cutting edge unified communication systems also can do this. Okay, paging and alerting. I kind of touched on this already. There's a couple different types. There's VoIP, which does the packetization, and then there's analog legacy, which are your overhead and your, I've been in these schools where they've got these, boards where there's like Viking clocks and time clocks and things that automate bells and stuff that happens over the overhead system. So a modern unified communication system has some way to integrate this into the phone system in some respect. There is quite a rich amount of features that can be provided here. Things like panic buttons, things like automated weather alerts. We set up one for a school where we've got a VoIP server that subscribes to an RSS feed from the National Weather Service, and if there is a watch or warning within this zone that they defined, it can blast out an alert to a group of phones. So you can get some early warning. You can use the same type of system. You can use the same type of system to do things like, the panic button, the active shooter alerts. You can send those silently, like so they're a pop-up on a phone. You can send out an actual page. You can do live audio paging. You can use phones as a speaker in your paging system along with the overhead. These are all things that a unified communication system needs to do. E911. This one's a bit of a hot topic because there have been some changes to this landscape over the past couple years. Notably, we have Kerry's Law, the Ray Baum Act, phases 1 and 2, and then the not yet passed in Indiana, Alyssa's Law, and that's really more of, hey, like this could come down the pipes. And I've got a little bit of a description of that. So Kerry's Law, I'm not going to get super legal here, but I'll just kind of summarize what these mean. And these are all, I think they're considered federal rules, regulations. So it's, they call it a law, an act, but what it amounts to is there's a degree of compliance, and if some federal entity were to do so and audit your organization, fines could be leveled if it didn't meet these. They're very real. I've never heard of anyone getting audited, but we all need to be prepared for these sorts of things. So Kerry's Law, among other things, a system must be able to dial 911, period. So, you've got phone systems where you dial 9 to get an outside line, and some of those, the administrator set it up so you have to dial that 9 in front of the 911. That's a no-go anymore. It has to route 911. It can still route 911, but it has to route 911. And, there's people ask me questions all the time like, hey, like, that's a problem because if we, do 9 for an outbound digit and then we're trying to dial some 900 number, which is a bit sus in the first place, but, like if you dial a 9 and then a 1, to dial just an area code with a leading 1, you're 2/3 of the way to dialing 911. There's a lot of misdials. So sometimes I got to go and convert phone system from using a 9 to an 8. Pretty common. But Kerry's Law says you got to route 911. Ray Baum Act. This one's more complicated. The phase 1 of this was passed in early 2021, and phase 2 was passed in January of 2022. And this has to do with location reporting information for those users that are dialing 911. So E911 is enhanced 911, and it means more than just someone dials 911 and it goes to dispatch somewhere. That's basic 911. E911 means there can be location information provided along with this call that gives the public safety answering point, the PSAP, detailed information. So maybe I've got a campus and we span an entire city block. There's one street address, but you've got 5 buildings, and those buildings, there's not a visual line of sight to every place in those buildings. Emergency responders need more because that can cost seconds, having to search for someone. So really that's where the drive behind this comes. E911 is, we need that information, and the Ray Baum Act, the first one basically, the first half of it requires that a multi-line telephone system, which is what we're talking about, to require adding that information. It should provide that location specific.
Question on that.
Yeah.
Have you been able to find any definition of what the Ray Baum Act means as far as specific location? Because I haven't been able to find anything. It doesn't say anything, not that I found, that says it's got to be every 500 yards. It's got to be every.
Yeah.
Is there any definition that says to be compliant with Ray Baum's Act, you need to specify X in your E911 call?
Yeah, you're talking, is there a degree of resolution that they
Yes,
require? Don't quote me on this. My research has indicated no, there is some degree of vagueness there, some ambiguity. And I think it's mostly a best effort thing. What I would say is if you go to, so Cisco actually, I said Cisco, there's an FCC page, and the FCC page does a good job of breaking down what it means. You know, instead of reading the bloody rule, you can get some human readable, you know, terms on this FCC. So if you Google FCC Ray-Baum Act, you will find this. And it goes into about as much detail as you're going to find. But
Yeah.
yes.
Okay, so I'm not alone.
No, you're not alone, not at all.
I'm thinking about my high school, right? If my high school's big,
Yeah,
what do they want? First floor, second floor,
yeah,
A wing, B wing, C wing?
yeah.
They kind of leave it out there.
You're right. You're right. And yeah, there's ambiguity there. I've set up this system so that a building is broken up into quadrants, northwest, southwest, so on and so forth. The system that we implement has the ability to put in GPS coordinates down to quite a many decimal places after it can get really, really, really micro. So I think the minimum requirement is street address of the building. Past that, I think it's just reasonable effort. I think the word reasonable is used in that rule somewhere, so, you know, from a legal terms,
So yeah,
that can be
very objective.
reasonable. My dad's an attorney, and he told me about the word reasonable once. So the Ray-Baum Act Phase 2 is kind of more interesting because it actually applies to nomadic phones. So if a soft phone is on your mobile phone, and you have the capability to have that service outside of school network, Ray-Baum Act 2, or Phase 2, Ray-Baum Act Phase 2 would basically say there has to be a way for that system to provide that more accurate location tracking. Right now, the best way in that specific scenario to achieve that is to block 911, so it forces the phone's native dialer to use its 911 location tracking service, so the service provider. Now, there are some ways that these unified communication systems do that, and they range in complexity, and they also exist in both the on-premise and the cloud format. And we can talk a little bit about that more and more. Meetings. So, on the page here. This is a content-rich experience that you can join with any device, PC, phone, what have you. You can share content in it, and an example would be WebEx, Zoom, Microsoft Teams, Google Meet. We got really familiar with this during the pandemic. That stuff is here to stay. At this point, it's pretty much clear that the advantages of having a cloud solution that does this far outweigh just having, an audio conference bridge on an on-premise system. We all know what to expect with one of these content-rich meetings. So based on that, I'm not going to talk about it much. It's certainly part of the equation, but I think you all know what to expect with this, and there's plenty of options out there. You've probably already considered a lot of them. So we're just not going to cover it for brevity. Okay, so these are the things that we care about. Now, for your specific scenario, you may care about some more than others, and that certainly makes sense. So moving on to the solutions architecture, what does this actually look like? What are the things that are required to make this work? So in this example, we have your on-premise system. So the first aspect of this is call control. PBX, you may have heard that term before. You may be familiar with like a room with like a gigantic monolith of clickety-clack line cards, and that was the PBX of yesterday. Today, those things exist as virtual machines running on servers. And those will handle like your phone provisioning, registration, so the phone can go out and say, hey, phone system, I want to start working with you. Okay, cool, we got this relationship. The dial plan, what can you dial, who can dial it, how that's supposed to work. It's really kind of the cortex, the brain of the system, and most communication flows through this component. Voicemail. We know what that is. I already talked about, you've got the voicemail, you've got the call flow, the auto attendant, you've got voicemail to email functionality. These are going to be users with mailboxes and auto attendants, phone trees, system directories usually live here. So this is going to be a separate application that lives in this server. Instant messaging. At its most basic form, AOL Instant Messenger, there's going to be another application that runs this thing in an on-premise flavor. Enhanced paging and alerting, and we've also talked about that a little bit. These systems can turn your desk phones into speakers for the paging system, and they can also blast out like text messages to desk phones and mobile phones, do panic buttons, trigger bell schedules. We talked about weather. E911, this is another application, and we talked about what that looks like as far as features. In more depth, not only can these applications provide that location-specific information, what it can also do is if you have a phone system where, say you've got a high school, you've got 1,000 people there, but you only have a couple phone numbers, and those are the main numbers that are used to call in, or certain members of the staff have them. Otherwise, your teachers, they don't have a direct phone number. They'll have an extension, they don't have a direct phone number. So the question is, if that person calls 911 and for whatever reason they are unable to complete that call, or they're unable to transmit the location and the nature of the emergency, how does the 911 call center call that person back, get more information? If they don't have a number that goes directly to them, they're probably blasting out the caller ID, the main number for the school. So what an E911 server does is it has this ability to track who calls 911, and whoever last dialed it gets a special number that it blasts out as caller ID, and if 911 call center calls that back, it routes to that last phone that called 911. So that's kind of some of the wizardry that it does. It also creates alerts. So somebody somewhere dials 911, an E911 server can blast out an email to a distribution list, to a group of people that said, hey, this phone, which is in this location, dialed 911 at this time. There's also record keeping. Who dialed 911 and when? You can pull that back if you have a suspicious call or an erroneous call that you need to look into. This is the place where you can go get that information. Moving on, there's a couple different types of gateways here. We have an edge gateway, and this is a very general term for a very complicated thing, but what it allows is that it allows desk phones and soft phones to work outside of school network without a VPN. And it does that by using this reverse proxy system. Basically, you've got a pair of servers, and they facilitate a secure firewall traversal tunnel that's initiated from the inside out and held open by Keep Alive. And so you take your soft phone outside of the network, it does a DNS discovery, it finds that element, and it's able to proxy your registration back through to the call control system so that you can have work phone that lives on your on whatever device, your PC or your mobile, and outside. So that's where I'll stop on Edge Gateway. PSTN Gateway. So this is a component that every phone system needs to have, and this can look different. There are a lot of different flavors of this, but it's basically one or more gateway appliances. So that might be a router, a gateway, actual metal device that brokers a centralized connection to the PSTN, the outside telephone world. So, like I said, those pairs of analog lines are still out there, they're still kicking. So that can be used. It's pretty common to see a PRI, one or more PRIs used in schools, and that's basically T1 technology. those are they're all over the place still. They're limited to 23 calls per PRI, and that's that was been the standard for a long time. And then we have SIP, which we kind of touched on. That's that protocol that governs the way calls on an IP network can be set up. And you might hear the term SIP trunk, and that doesn't refer to an actual thing you can grab. That's a logical link, but what it is it's a definition of a traversal path from one gateway to another gateway, and that other gateway might be with a telco, a telephony service provider. And that trunk allows multiple calls to go over it. And your only limit there is if you have if your telephone plan includes X number of sessions, that means concurrent calls, so 50 calls at once. You might be limited by that. Otherwise, the only limit is how much bandwidth do you have on this thing. It's the current industry standard, and it's an extremely flexible thing.
Is there more than one term for that? I've heard call paths, or even
Yes.
the licensing features is what you'll run into, or I forget how many call paths they say you can get on a 100 meg link, which was more than we'd ever need when trying to size the outside world call paths or concurrent phone calls
Yeah.
inside the district at one time.
Yeah, that's the same. It's the same term. Call paths, concurrent calls, sessions. A session is basically comprised of two call legs. Me to you and you to me. So yeah, that's all the same thing. And so often there's billing that's based on that.
One piece I want to throw in here, if you think about it, is something we've had the most of is hotline management. The ability to make schools have the traditional call paths. Parents calling in, they call the main secretary, they route the phone call to where it needs to be, or you have the auto attendants. But we run a tech hotline, or if there's an event hotline, we need to be able to set those up and have more advanced controls of either assigning it to phones, who's going to answer them, or that flow process. The main auto attendant secretary didn't answer it. After 3 rings, it should go down a phone tree.
Yep.
Those are some very nice things I'd like to look for in the next phone system, along with reporting.
Yep.
I want to know in the hotline, how many phone calls did we get in tech support hotline phone calls? 10 per hour, 2 per hour. What's our ongoing rate so we can staff it? Who in the staff is picking it up? So reporting, to me, should be a huge part of the next phone system era too.
Yeah. And I'll tell you what, I don't really touch on it in this presentation. I kind of take it for granted because it always just comes with the solution. Now, the readability of those reports can be something where sometimes another product is required to make it look better. But that data is being aggregated by the system, and if you're clever with Excel, you might have an automated way to do that. But that is absolutely a component of a unified communication system, and I would call that a commodity. It should come with it. It should.
Well, from experience, I know it's not. That's why it shouldn't be forgotten. It should be tailored. In 2016, we changed our phone system. Things you had to go down through is how do you determine how many call paths? AT&T would not give me that number, no matter what. You couldn't find a person to say, well, how many do I need?
Right.
So you just size the same as it was.
Yeah.
Those are the essential tools when I think talk about new phone systems.
Yeah.
In coming up with those reports of where is your highest call load? They get into school and then it tapers out.
Yeah.
In or outgoing.
It is important, and the product should offer some offering that has analytics. With the Cisco solution that we implement, that's actually part of the cloud dashboard, and that's actually one of the big selling points. Is because that all is compiled and put into like a meaningful graph out of the box. The on-premise solution generates all that data, and if you're clever with choosing the right buttons and knobs, you can have it output a PDF that gives you a graph. Not user-friendly. So yeah, that's something, and kind of the things that you're talking about is almost like a call center.
Yeah.
And there are even supplemental applications that are designed just for running call centers. Usually there's some overlap with what the PBX can provide, call queuing, hunting, and rollover, and those sorts of things. That's all pretty standard, but the more call center type stuff, there are specialized products just for that. So yeah.
So when hunting phone systems, are those usually, you've seen them being add-ons or specialty products or specialty appliances that were out there?
Yeah, I think we have one customer that's a school that uses something like that. Majority of them don't dip into that because just the base functionality that the system provides seems to suffice. They have consulted with us about how do I go through the steps, what's the workflow to get the analytics that you're talking about, because it's not always obvious. It is on the cloud side, and so you have something with a really pretty dashboard. It's designed to do that. So yeah, does that answer your question?
I think at that, I was just trying to steer maybe a little conversation, trying to do, wasn't quite sure where you're heading with the discussion, and I was trying to see where these pieces all fit together.
Yeah.
Or to define what most schools may be looking for.
Yeah. Let's go through, and I can get more depth into that at the conclusion of the session if you want to. I'm about past the halfway mark, and still got some to get through here, so I wanna make sure you get that. All right. So we touched on PSTN gateway, and then survivability gateway, and that is that ability to provide dial tone if everything else goes down. So there is redundancy in a modern system, and I'm going to move on to some diagrams that I built out to show you what that looks like. So there's generally redundancy in clustering of the actual call control, the voicemail. In a well-designed system, there's going to be redundancy in that PSTN gateway. But good phone systems are like ogres, which are like onions, and it's always best in layers. So you have that redundancy there. You have redundancy in the PSTN gateways. And then the last line of defense is going to be a survivability gateway. So this would be like an elementary school that doesn't have one of these PSTN gateways. They get their communication over the fiber ring that you've got running between all the schools. What happens if that gets cut, if somehow they get cut off? Well, the survivability gateway will allow you to use those couple POTS lines you've got there for some. Usually I reserve one for 911. It can only be seized for a 911 call. If we have more than one, then maybe we can let someone order their pizza or whatever, but I want to make sure that there's a line always available to dial 911. That's how I do it. And last but not least, we have the endpoints, the phones. This can be video conference system. This can also be a soft phone. This is pretty obvious. So in a nutshell, that's an on-premise system. So at its very basic level, this is what a cloud system looks like. Pretty stark comparison here. Basically all of the things that I just described, the call-controlled PBX, voicemail, so on and so forth, they are all running in a set of replicated data centers across the country, across the world. That data, your phone system data, is replicated in multiple places for redundancy. This is what it looks like. All that communication from the phone goes out to the internet, comes back to you. And that does raise some kind of interesting questions, some implications, and we'll try and touch on how a mixture can really give you more of an optimal experience, especially when we're talking about reliability and we're talking about latency sensitive applications. That's voice communication, and that's also video communication, latency sensitive. We all know what it sounds like when someone's garbled on the other end, or when there's like a 3-second delay between you talking and hearing someone else. It breaks the whole flow. So, moving on, what we see more often than not is a mix. And it's a mix of components on-premise or in the cloud where it makes sense. So, like when we sell an on-premise system today, we always position a cloud version of the instant messaging. It is just so easy. It just works out of the box, and it makes sense that text messaging can just work anywhere, and quite frankly, it just comes with it. So we still have some customers that insist on having an on-premise solution to deal with that, but a vast majority of them say, yeah, this is okay for this service to be in the cloud. In this case, what we'd be looking at is a system that is based in the cloud, but there are some on-premise elements that carry some specific roles. So in both solutions, an enhanced paging and alerting system has to have an on-site element. And that is because most likely that system is going to use multicast, which is something that's a network technology that is inherently within the LAN. What we see more often than not is there is a server that runs, one or more. They can be redundant. But it has a cloud dashboard, and it can do cloud integrations, and it does use a cloud integration to trunk back to a cloud-based phone system. So as somebody making a blast page, they'll get on their cloud phone, and they'll go off hook, dial the things. It goes out to the cloud, comes back to this point, and then it propagates multicast out to all these phones. They all go on speakerphone, and the voice propagates. It takes a bit of a long path, but this is how multicast works with a cloud phone system. PSTN gateway. So some of these cloud phone systems, they can use an integrated PSTN option. And what that means is that one of these PSTN providers like an AT&T, a Peerless, so on and so forth, they have a point of presence in the same data center as the cloud phone system platform. And so it makes sense for them to have a really low latency trunk directly there. So if it makes sense, you can have PSTN provided specifically at that cloud platform location, and you don't have anything on premise where that PSTN connection is terminated. Then you also have the option to use maybe a SIP trunk, a PSTN connection that you were using when you were still on-premise. There is flexibility here. And basically the PSTN gateway has a special amount of programming. It can create a trunk out to the cloud system. So when a call comes in, it comes into your premise, and then it signals the cloud PSTN system, or the cloud phone system, and that causes your phones to ring. Now there is so you're probably thinking like, okay, that's a long path, right? And we don't like long paths with voice. Latency's, many hops means many opportunities to introduce latency into the equation. We don't like that. So that's why there is this bit of wizardry called media path optimization. And I'll touch a little bit more on that later, but basically it allows the voice, the transmit and receive audio, to be routed locally while the signaling still takes that long path. Survivability gateway. This exists for a cloud phone system. I don't know if it exists for all cloud phone systems, but it does for the one that I know and love. And I'll get more into that a little bit later. So that's kind of what a mixture looks like based in the cloud. I kind of already described this. You can have an on-premise system that also has a mixture. So maybe you have call control, voicemail on-premise, but instant messaging is a cloud service. E911 is a cloud service, and that paging system, it has an on-premise element because of the multicast thing, but it's got a dashboard with integrations that work in the cloud. So more often than not, we see a mixture, and it basically just means that there's been thought, there's been a discovery, there's been a design that takes advantage of the reasons why we even consider a cloud service in the first place. Okay, here's some drawings. Okay, so there's a lot going on here. This would be a kind of a best practice design for an on-premise system. So, and this is a generic school district. We've got a primary and a secondary locations, and in this model, these would be kind of a hub. And then we've got a local elementary school that they probably feed into a middle school, into a high school. There's more of them, and so this would be your typical spoke. And so you see here, the black is kind of like the physical hookup. The blue is where that SIP traffic would run, and then the green would be like a POTS line, and the red is how that traffic routes if it gets cut off, the survivability traffic. So you see here, we've got these elements. Basically, this looks like a server that's running the hypervisor like VMware, and it's running a bunch of virtual machines that are in a clustered relationship with its counterpart over here at the secondary location. And a cluster allows for load balancing, failover. So if you have two call control nodes, they both have the ability to sustain the phone system. When everything is good and there are no problems with the system, half of that is providing service to half the phones, half of that is providing service to the other half, and you've got load balancing and all as well. So the same can be done with voicemail, paging, E911. I put Edge Gateway in here just to show that is also a virtual machine. I could spend an entire hour talking about that thing alone, but it's part of it. And so we also see we've got a SIP gateway at each site. And so that provides the redundancy. There's two SIP trunks here going from the same or different providers. And if one goes down, the other can pick up. Usually there's a flexible licensing model where these two gateways share a pool of licenses, and the same is generally offered by the SIP provider. And then again here, the local elementary school has this survivability gateway so that if it gets cut off, it can still sustain, it can definitely sustain calling internally. Phones can 4-digit dial other phones in here, but they can also get some, I just clicked that. They can also get some basic calls out. All right, moving on. So here's that kind of minimalist cloud system again. Like the most basic cloud system is just phones. They need power over Ethernet so that they come on. They need a connection to the internet. That's it. In its most basic sense, that's what a cloud solution looks like. So all of the signaling, all of the voice, it all goes out here, and it goes from the internet to the cloud calling platform and back. Okay, so where things get a little bit more fun is this would be a model where you've got a cloud calling system that has local gateways providing SIP service that were maybe there before when everything was on premise. They can be reused in this. So if you have a special pricing set up with an AT&T or something like that, and you already have these SIP gateways here, you can use those in the cloud setup. And it does a media forking where a call comes in here, the signaling goes out to the cloud, rings the phones, the call gets set up, but due to media path optimization, that audio path is actually going to go from the local gateway where the call came in directly to the phone. And so we can combat some of the negative aspects of having a service out in the cloud by doing this media path optimization. And then here you can kind of see the internet. Usually the internet service providers, are co-located with the cloud, the data centers with the cloud calling platform. So there is still a last mile element here, but between an internet service provider and a cloud calling platform data center, there's generally internet backbone type throughput that you can be expected here. All right. Moving on. So this is a model where it's similar. However, we've got cloud integrated PSTN. So instead of using those local elements, there is essentially a SIP trunk that terminates our cloud phone system that's also in the cloud. So what that takes advantage of is the low latency backbone link that likely exists between the PSTN provider and the cloud calling platform. And so in this model, the media path optimization can still take place if, say, this phone at admin building calls this phone over here at the high school. If this is configured right, then all the signaling goes out to the internet, and once that call is established, the shortest path that exists, on the WAN between these two buildings can be taken for that media, and so you can still get low latency communication. Here, what I'll draw your attention to is because we're doing that PSTN connection in the cloud, that kind of takes away that on-site element for getting dial tone. So in this case, a survivability gateway, with a POTS line or two. Maybe you want to keep a PRI around for kicks. Hey, but you have a backup connection to the PSTN here, and that's what happens if you lose internet. Okay, so let's get to the meat of this thing, compare these two, which is essentially the last part of this presentation. So care and feeding of the system. With an on-premise system, these need servers, rack space, power, cooling. Both solutions need switches with PoE, but the obvious lack of gear is I'm going to give this the advantage to the cloud. As far as application and OS, the on-premise phone system needs upgrades. There's product life cycles that are going on here. There's terms of support. You need to be running a supported version to get support. This is all maintenance and upkeep that's required of an on-premise system. Upgrades still happen to a cloud system. They're performed on a very regular maintenance interval, and they are all performed by Cisco. They're all performed by the cloud service provider. So, whereas these upgrades give people like me a job, as much as I like doing it, I'm still going to give it to the cloud here because it's easier for you guys. All right, management. If you guys have ever seen a cloud dashboard for network infrastructure for servers, you know that these are products that are designed to be easier to manage. And there's no exception with the cloud system here. The on-premise system is probably going to use a web GUI, and in this case, each cluster of applications will have its own. So we're still talking about separate systems here. There's still modularity, but each system is going to require its own view into the management interface for the thing. With a cloud solution, in general, there's 1, 2, maybe 3 points to manage the thing, and it is just far easier to manage. So for this one, I'm going to throw Winter Cloud here. Moving on, performance. So the on-premise system is going to ride on top of the local LAN infrastructure, and because the on-premise system is on the same LAN as all the endpoints, There's only a few network hops. We already talked about that. That's a positive impact on performance because less hops in general is lower latency, which is better for voice and video. The cloud solution has to take that long path. If you want to call the person next to you, that signaling still has to go up to the internet, to the PBX, and still has to come down to them. However, media path optimization can resolve a lot of this, and it can give that performance. Once the call is established, it can give performance similar to that of an on-premise system. However, setting all things equal, the on-premise system, by definition, is always going to give better performance, because just by definition. So I'm giving this winner to on-premise system here. Features and customization. And this one is a little bit of difficult one. The on-premise system is generally the benchmark for customization. There are thousands of knobs and levers on these things. Someone like me who's done it for 10 years, there are things I don't even know they're there and will never use. But there are scenarios where they can be used, and the on-premise system contains the whole back library of all the features ever successfully implemented in one of these things. So that in and of itself is significant. So the cloud system. It's a little bit different here. In general, the cloud system should provide feature parity. All your core requirements should be met by a cloud system if you're considering it. Implementing with customization options, every now and then we run into something that the cloud system doesn't do in the same way. And sometimes that is about getting used to the way this one does it. The same outcome can be achieved. But the cloud platform doesn't do everything that the on-premise platform does. That 15% may not be things that are even pertinent to what you guys need. Now, where cloud does have an advantage is the fact that in general, these features, which can be very complex and require somebody like me to spend hours building out, they just work with a cloud system. They work out of the box. They come pre-configured. But with an apples to apples comparison, the on-premise system will do more, just by definition. So I'll give that one to on-prem. All right, security. This may or may not be applicable to your situation. A lot of our customers, security, as far as encrypting the voice traffic, encrypting the signaling, they're not as concerned about that because an on-premise system runs inside the LAN. So I think the idea is that if the LAN is secure, then everything inside the LAN is secure. And there's something to be said for that. Now the on-premise system can do all of the security stuff and to quite a high standard, like Department of Defense. It can do all this stuff. The complexity increases quite a bit. There's a pretty high reliance on certificates and certificate renewal. I'm sure we all love that. But that's what it takes to do that on an on-premise system. On the cloud system, this can be different across the different products. So speaking from the experience with the Cisco, that's one of the differentiations of WebEx calling and Cisco is that it comes secured. It does the encryption, the secure RTP, the secure SIP. It does that out of the box. The other solutions can do that too. It might be an upgrade or a bolt-on or an add-on, but a cloud system can provide that same level of security. So I have to call this, in an objective sense, this is a draw. They can both do it. So it's just which is easier, which does it out of the box would be the differentiating factors in my opinion. Ease of use and administration. So I am living proof that an on-premise system takes somebody with a specific set of skills to build out, to troubleshoot. We provide training to our customers when we basically hand over the keys to a system we just built, and we try and equip them with what they need to do. Ooh, I'm way over time, aren't I? All right. We tell them how to do the day-to-day stuff. The difference here is the cloud system is designed to be easy. And we know that you guys wear lots of hats. You don't have the time to go and be a voice engineer along with being everything else that you guys do. The cloud solution is designed to do it in an effective, straightforward, simple way that you can just get the thing done, move on to the next thing. So I give the advantage here to cloud. This is probably the most important thing I'll talk about. Reliability. The on-premise system, I've seen these things run for 6 years straight without a reboot. Usually there's another failure point. It's going to be SIP provider, it's going to be some power event. It is generally not the actual phone system that causes an outage. It's usually something else. So, onto the cloud. There's an obvious failure point here, and it's the internet connection. And there are some locations where internet connection is just not reliable. Last year, my presentation would have been, why not to go cloud? Because basically the way you're supposed to ensure redundancy in a cloud system last year was you just need 2 internet connections. If one goes down, you got the other one. To me, it's kind of like, well, yeah, but with the on-premise system, we can use like phone lines, POTS lines and stuff. What's the deal? In the last year, survivability gateways have become compatible with the cloud calling solution, and they can provide the same amount. So the advantage here is a draw. They can both do this now, but I think this is probably the best outcome here because this is no longer a determining factor. They can both do this, and I think this is the best of both worlds. Finally, financial impact. With the on-premise system, you own a thing, so it tends to be more of a CapEx, capital expenditure thing. But account managers, they know how to run numbers and everything, and they can lease a system, they can payment plan a system. All right, cool. The cloud system is a subscription model, and that's a decided factor.